Hi, my name is Patrick, and today I will show you how to compromise a Kubernetes cluster from the beginning of the web application to the Kubernetes nodes. Furthermore, I will show you how such misconfiguration and vulnerabilities can be detected over the lifecycle of a Kubernetes application, as well as across the different layers of the Kubernetes infrastructure. For this, I have started up a Kubernetes cluster in AWS. This cluster consists of two EC2 instances running the Kubernetes cluster. Furthermore, I wrote a Kubernetes manifest that contains the damn vulnerable web application deployment. The damn vulnerable web application is just an example. It could be any other web application that contains vulnerabilities. As you can see, here are the two EC2 instances that running the Kubernetes cluster. And also you see the pod that is running the damn vulnerable web application. In the first step, I want to compromise the damn vulnerable web application and gain administrative rights. That means root in the running container. Further, I will perform a container escape to compromise the underlying EC2 instances and to gain all administrative rights of the Kubernetes cluster. The attacker exploits a remote code execution vulnerability in the damn vulnerable web application to execute multiple commands within the container via the web page. This involves executing commands that cause the container to download malicious code from the attacker's web server and execute it. Then the execution of the malicious code establishes a shell connection from the container to the attacker's machine. This console is the web server that is running on the attacker's machine. This console is the port listener that is also running on the attacker's machine to listen for the incoming connection from the container. This is the damn vulnerable web application. Normally, an IP address is entered here, and the application takes the IP address and executes the ping command in a shell. Now I execute a curl command to download the malicious binary from the attacker's web server via the remote code execution vulnerability. As you can see here, the container successfully downloaded the malicious code. Then I have to make the binary executable that we downloaded via the curl command. And execute the binary. As you can see here, we got a successful connection from the container. To get the shell, just type shell. And quickly check which user I got. I got the user www-data. In order to perform a container escape, at first I need to gain root privileges inside the container. For this, I used the PwnKit vulnerability, which was published in January this year. In the first step, I download the compiled code of the PwnKit vulnerability from our public S3 bucket and execute it. For this, I have to change the working directory. Then I download the malicious binary from our S3 bucket. Make the binary executable and execute the binary. Quickly check if we got root rights. In order to perform a container escape, we need to issue a few commands to create and execute a new C group and a shell script. The shell script downloads a malicious binary from the attacker's web server and executes it afterwards. The execution of the malicious binary established the shell connection from the Kubernetes node to the attacker's machine. Let's go through the commands. At first, get access to the memory C group controller and create a new C group within that controller. Register notify on release for that C group. Set the release agent to a file that's accessible via both the container and the EC2 instance. The shell script contains the curl command to download the malicious binary from the attacker's web server. Make the binary executable and execute it. Now you can see that the EC2 instance downloaded the malicious binary from the attacker's web server. And here we received the shell from the EC2 instance. And now check the hostname to know which EC2 instance I have compromised. I have compromised the EC2 instance 253. That's this Kubernetes node. Let's quickly summarize how I gained full control of the Kubernetes cluster. At first, I compromised a vulnerable web application and gained root privileges via an unpatched vulnerability. Then I performed a container escape via a misconfiguration within the Kubernetes cluster. Now I will show you how Mondoo can help you to analyze a Kubernetes application for vulnerabilities and misconfigurations throughout the complete DevOps lifecycle, as well as across the different layers of a Kubernetes infrastructure. Mondoo provides me the ability to scan a Kubernetes manifest. This could be integrated into a CI/CD pipeline. Let's analyze a Kubernetes manifest. You will get the results in the CLI. As you can see, in the Kubernetes manifest is defined that the application runs as a privileged container. You can also view the results in the Mondoo dashboard. I just enabled the Mondoo Kubernetes application benchmark. You can see here that the Kubernetes manifest defines the application as a privileged container. Mondoo can also analyze a container image offline. That means the container image is not running. Mondoo downloads now the container image from the AWS registry and analyzes it without running the container. In the CLI, you can see that Mondoo detects some vulnerable packages. I use this vulnerability to perform the privilege escalation. Mondoo shows you the inside package version and also which version I have to update in order to fix the vulnerability. You can view the results of the container image scan in the Mondoo dashboard. Just copy the link from the CLI. Here you can see the results of the Mondoo scan. And here we have the policy kit. You can click on the CVE to get more information about the vulnerability. I'm also able with Mondoo to scan the Kubernetes cluster for misconfigurations. As you can see that my Kubernetes cluster is not hardened, so I have some misconfigurations. It is also possible to view the results in the Mondoo dashboard. Furthermore, with Mondoo it is possible to connect against the Kubernetes API and get current information about the status of the cluster and the containers. This means you have a question. Okay, then ask your cluster via the Mondoo shell. Now I want to ask the cluster, please show me all running container and if the container identifier type is a digest. As you can see, a couple of containers are having a digest and others are just having a tag. Also, I can analyze the EC2 instances of a Kubernetes cluster via the AWS System Manager agent. This means I don't have to expose the SSH service to the internet. Mondoo is able to connect to the EC2 instances via the AWS API. Let's have a look at the results in the Mondoo dashboard. As you can see, Mondoo identified some missing patches and some misconfigurations in the Amazon Linux operating system, as well as some misconfigurations in the Kubernetes cluster. The last missing layer of my infrastructure is the AWS account. I can also analyze the complete AWS account with Mondoo. And here I get my results again. I'm also able to establish the Mondoo shell to the AWS API and get some current information about my EKS. And I get the current configuration of my EKS cluster. As you can see, everyone in the internet can reach my Kubernetes API. Thank you. Please go to mondoo.com and sign up for a free account to analyze your Kubernetes cluster or your complete infrastructure for misconfiguration and vulnerabilities.